Hello, my name is Doug Kopp. I am the Rescue Chief of EPRC, the American Rescue Team. My personal experience comes from working 76 disaster events and having tunneled inside of 650 plus collapsed buildings. I hope that the knowledge I have acquired from these rescues will be of some benefit to enhance your skill level and personal safety. Urban heavy rescue, dangerous structure technology, is an area of rescue responsibility which is moving to the forefront of interest with fire and police departments, certainly on a worldwide basis. However, this film will focus on unique logistical, material, technical, environmental, and cultural requirements unique to urban heavy rescue within the United States. Historically, there has been a need for rescue from collapsed structures since man first moved into a cave which fell on top of him. Modern times, with our concrete jungles, have created a unique demand upon those who rescue. There are those who think that the structural quality of American structures is such that the lessons to be learned from structural collapse in other parts of the world are irrelevant. I hope to illustrate that this is not the case. It is true that American structures are built to a very high level of quality and structural integrity. However, the forces generated by natural and man-made disasters do in fact surpass the ability of American structures to maintain their structural integrity. The moderate earthquake in San Francisco, 1989, Hurricane Hugo, etc., illustrate that structures built to the standards of American building codes have collapsed and will continue to collapse. Structures in a collapsed state are different depending on a multitude of factors involved in the collapsed causal link. The form of the structure, the mass of the structure, the characteristics of the force applied. My experiences have taught me that every individual collapsed structure is almost like a person's signature. They are unique within themselves, and the rescuer must keep an open mind to see the differences between different structures. Awareness of these differences can mean the difference between life and death. It must also be remembered that there are generalities among different collapsed structures which can be rightfully applied in 75% of cases. If we give a definition of urban heavy rescue as the rescue from complicated, often dangerous, collapsed structures, usually in an urban or high-density environment, involving the use of rescue resources normally available to a highly budgeted rescue team, this video addresses this definition of urban heavy rescue. Let us now break down UHR into the individual components. The life locating team is the reconnaissance of the UHR. It is the responsibility of the life locating team to gather the intelligence which will allow the UHR resources to focus on the specific areas most likely to contain life. This is critical to expedite the rescue and becomes more important to UHR success in direct proportion to the scope or magnitude of the disaster. During the initial phase of the UHR, they will work closely with the tunnelers to locate and rescue those victims who can be easily accessed without the necessity of other UHR components' involvement. Next, the life locating team may identify locations in which victims are conscious and actually acoustically heard by the unaided ear. Life locating using dogs is extremely useful in an open space environment and limited structural collapse. S&R dogs generally are very loving, affectionate creatures, and like humans, they become stressed, worn out, and emotionally overwrought with a prolonged UHR. Site spraying of decontaminant prior to dog S&R voids dog S&R. From a practical point of view, in a sophisticated UHR rescue, they have restricted practical use. There are a number of electronic devices currently available which use acoustic and seismic signals to locate live victims. There are also gas analyzers which can locate dead victims by detecting presence of gases peculiar to decomposing bodies. Life locating is important and complex enough to warrant being the subject of an entire film in the COP Life Systems Library. Part of this film also shows the 9 major life locating devices in the world being demonstrated at an OFDA-sponsored life locating competition. Experience and/or knowledge of common victim response procedures is the key to rapid location of both live and dead victims. The knowledge of the interiors of collapsed structures can be the most significant factor in determining where to focus UHR activity. The experienced tunneler can view a structure from the exterior and pinpoint the locations where victims are most likely to be alive, where victims are most likely to be dead, and the areas containing the greatest concentration of dead victims. Some examples. Usually, when wooden structures collapse, they break up into many pieces inside. This allows for the existence of a large number of voids or safe areas post-collapse. Consequently, this type of structure currently has the highest survival rate. You will find live victims in voids in front of sofas, next to bedroom mattresses, and around kitchen cupboards. In general, large, bulky items which allow for a safe, open void or space to exist surrounding them post-collapse are the areas where rescue activities should be initially focused. Victims who get under objects, such as desks or tables, are usually killed immediately. By placing their body in the direct line of applied force, these victims die when the table or desk gives way to the floor above. In other words, if you get under something that is crushed, you will be crushed. If you get next to something that allows a safe space to exist around it, you will probably be safe. In the interior of a brick building, live victims will be found in the same safe voids. Brick walls are different. They tend to break up into very small chunks or individual bricks. There will not be any voids existing around these objects post-collapse. The perimeter of this structure is the only area in which a higher degree of survivability will exist because of the duck and cover technique. Duck and cover is not appropriate in total collapse. Multi-story curtain wall, steel frame construction, and multi-story concrete structures are very similar. 95% of live victims will be found near the outside perimeter of the structure, and the bulk of these survivors will have extricated themselves in the first 20 minutes post-collapse. The victims who run to the interior will need to wait for the entire building above them to be removed before they can be extricated. These are the victims who are called the miracles because they are found alive 10 and 12 days post-collapse. Unfortunately, they are quantitatively the victims who usually suffer the most prolonged and agonizing death. Stairwells have a different frequency of movement than the bulk of the structure. When the swing is out of phase, the greater mass of the main structure will knock the stairwell down. Stairwells are typically one of the first parts of a structure to collapse, have an almost certain death rate, and the stair treads severely mutilate the victims. Elevators, are similar to stairwells in that they collapse initially. However, an extraordinary event can take place. The elevator may reach the elevator pit before the mass of the building collapses. If the elevator did not have too far to fall, then surprisingly, survivors are likely to be found when the ground floor is removed. In basement garages, there tends to be a high survivability rate. The vehicles leave many large voids around them post-collapse. Any victim walking to their car at time of collapse who did not have enough time to mistakenly get inside of their vehicle has the best chance. You will find survivors inside of vehicles if the weight of the floor above was not great enough to crush the vehicle beyond the amount of space required for survival. Victims who remain in their vehicles are usually crushed to death. Parking garages and freeway overpasses are constructed to support a heavy vertical load. Unfortunately, the larger mass of these structures result in a greater swing to the horizontally applied seismic waves. These structures collapse relatively easily compared with other structures. Live victims will be found next to their cars. Dead victims will be found crushed to death inside of their vehicle. 99% of the victims located in the middle section of the Nimitz Freeway collapse died because of crush syndrome injuries. A safe space existed around all of the vehicles on the middle deck. If the victims would have crouched next to their vehicles instead of remaining inside, 99% of the victims would have survived instead of 99% dead. The presidential compound in the El Salvador earthquake of 1986 is a classic example of a pancake collapse involving many deaths between the slabs. Schools and office buildings are of this type. The large concentration of deaths prevent the floors above from breaking up. These structures tend to pancake or stack up. The individual deaths give many points of vertical support to the floors above. The deaths have a tendency to give way during the collapse. Following the collapse, expect the deaths to have become one-half their original height. The victims under their desks tend to be mutilated, except for their feet sticking in the aisles. These types of collapsed structures are the safest for tunnelers should an aftershock occur, because the desks have given the structure an inherent high degree of stability. These types of structures, because of the wide open aisles remaining post-collapse, are very easy to search. Movement for the tunneler is relatively unobstructed. Commonly followed victim response procedures have resulted in 95% of victims dying, no matter what country or what the cause of collapse. The victims who panicked and were unable to get under their desks will have the highest probability of survival. Let us now deal with the most sophisticated UHR activity, the rescue from a multi-story collapsed structure using all available UHR resources. First, we'll identify key strategies. Number 1, if you have a multi-site, large-scale UHR, clearly and properly assign areas of jurisdiction for the teams. Be these teams from different cities or different countries, the purpose is the same: to maximize the effective use of logistical, material, and strategic resources in the UHR without duplication or reduction of effort. Every UHR participant in the USA is well aware of the possible life-threatening problems jurisdictional disputes can generate. Number 2, UHR must be undertaken with whatever resources are available. Those officers who have never experienced a major disaster must realize that a major disaster can require a whole new set of rules. The method explained in this video for slab removal from a pancake collapse will illustrate UHR, the most complicated type of UHR, maximizing the use of the most sophisticated UHR resources available. Once the trainee understands this rescue, all rescues will be addressed. If heavy equipment is not immediately available, the rescue can be completed by using the remaining components. Number 3, coordination and communication. All rescue activities must take place simultaneously. Time must not be wasted. It has been commonplace at many UHR incidents for UHR components to conduct their rescue efforts on a contiguous basis rather than a concurrent basis. This is a serious mistake. Rivalries and individual efforts must give way to a synergetic team approach. Experience has shown that coordination and continuous communication among the UHR components will result in a safe, expedient effort with everyone working together. The bottom line is that the time required to extricate or rescue the victim can be reduced to 1/5 of the time otherwise required. Number 4, write it down in big letters with fluorescent paint for everyone to see. If the rescue at a site is completed, mark it on a wall or street for everyone to see. If there is a live electrical wire or gas leak or toxic spill, etc., mark it down. You would be surprised how many times some buildings get searched while others go without. Even on a large site, make it clearly visible for the relief shift to see. Any information that is worth knowing is worth the time to mark it down for everyone to see. Number 5, with specific regard to UHR resulting from an earthquake, understand that an earthquake is not a single seismic event. Rather, it is a period of increased seismic activity, with thousands of earthquakes occurring, most of them too small to be detected without a seismic recorder. Be wary that an aftershock as large as or larger than the initial shock can occur without warning, usually when you least expect it. The incident site commander should position himself from a perspective to enable him to keep a close and constant vigil on all the UHR team members. Remember to keep safe and only take chances when necessary. It's simple. If nothing can fall on top of you, then you are standing in the right place. Anticipate. Let us begin with the UHR site chart to explain UHR components, methodology of application, responsibilities, placement of resources. The graphic on the screen represents the top view of a multi-story collapsed building. The intersecting lines represent the carrying beams, which lie directly below the slab. 2 cranes are positioned to cover as large a work area as possible. The staging area is also shown. Of primary importance is to use all resources available concurrently. Consider each square area bounded by the carrying beams, namely each bay area, to be a separate rescue site. In this particular example, you would have 20 rescue sites. This approach will greatly speed up the rescue process and allow many teams of workers to perform the same rescue activities in different areas of the collapsed building simultaneously. Hand labor using jackhammers should punch out 2 holes in the center of each bay, approximately 3 feet apart. A choker or a cable with a loop on each end will be passed through these 2 holes. The loops of this choker will be slipped over the crane hook. The crane will now apply tension to the slab to bring it taut. The crane should not try to lift the slab. The intention is to make the area under the slab safe for tunnelers by eliminating the possibility of the slab collapsing or falling downward. A second jackhammer crew should be cutting and opening entry holes, usually 2 feet by 2 feet square. The tunnelers can now safely enter to search the slab below for victims. A third jackhammer crew should be cutting a path approximately 10 inches wide on the inside of the carrying beams. The graphic on your screen illustrates the slab with the concrete removed just inside of the carrying beams. The slab is now ready for the torch crew to cut the exposed rebar on 3 sides. It is standard operating procedure to use duct tape to secure the burning torch on the end of an 8-foot pole. This will allow the cutting to be done from a safe distance. At this point, the crane will lift the slab in the air. The rebar will bend on the side still attached to the slab. This will look like a sardine can with the lid lifted up. While the crane holds the slab snug, the torch crew will cut the rebar on the remaining side. After the last piece of rebar is cut, the slab will swing up in the air and balance itself with the crane cable acting as its fulcrum. The crane will place the slab in the staging area. The staging area should be located as far away as possible from the rescue site. The bulldozers, backhoes, and bobcats produce destabilizing vibration. Additionally, it may be necessary to have a jackhammer crew breaking up the slabs into pieces small enough to fit inside of the loader's buckets. The concrete is now ready to be loaded into the trucks for removal to a dump site. Let's consider the size of the slab that can be lifted by the crane. The crane rigger will understand and be well aware of how much weight the crane will be able to lift without breaking the boom or breaking the shear pins holding the boom. It is necessary to rely on his judgment as to how much slab you can lift at one time. There will be many pieces of rubble that must be removed by hand labor. Plywood should be placed across the structure to make a ramp for wheelbarrows to be wheeled down to the loading area. These barrows can be filled up with small pieces of concrete. A second labor group should form lines to the staging area and pass hand to hand as large a piece of concrete as possible. Usually at disasters, this labor will be provided by the Army, volunteers, Boy Scouts, or similar groups. The incident site commander should be placed in a strategic position where he will be able to watch all the individual rescue components conducting their work. The life locating technician, using an electronic life locating device, can place his probes immediately above any area where it may be suspected that a void or possible safe area is underneath. He can then check for life using this device. The key to this entire program is to make sure that all of the activities are going on simultaneously. Frequently at disasters, the life locating technicians stop all other work from taking place while they check for life. Other times, dog handlers stop all other work while they check for life. In both cases, it is a waste of time to have independent activity. Only under extremely unusual circumstances should other work be stopped. For example, if life locating devices are picking up a signal from an unconscious victim. The advantage of the COP method is that the entire operation can be completed rapidly and safely. No pressure or weight has been placed upon the structure or a victim trapped underneath. Quite the contrary, stress or weight has been constantly removed from the site. Minute by minute, the site has become more stable and safer. A nursery of newborns could rest underneath this slab and be rescued quickly and without injury. As many cranes as available, as many torch cutters as available, as many jackhammers as available can be working any number of bays at the same time. The only limitation is the quantity of resources available. Number 1. A major disaster is very different from routine rescue. Different strategies and procedures are sometimes required. Number 2, always remember, every minute means a life and every mistake a death. Number 3, stay alert and think. Take only necessary risks. Pay attention. Always be ready for the exception to the rule. Number 4, more often than not, the rescue team will be approached by a civilian who will swear that he heard a baby crying from inside of the collapsed building. This usually takes place after the building has been searched by a previous rescue team or at the time the rescue team is discontinuing the search to relocate to another rescue site. This must be taken with a grain of salt. The usual case is that the civilian has a relative still inside of the collapsed building. Consequently, he does not want the search discontinued. The incident site commander must use his best judgment in deciding the validity of the civilian's assertions. Number 5, at disasters in America and around the world, it is commonplace for a local rescue team to look at some mangled, twisted, flattened structure and think, nobody could possibly survive inside of that. The truth is, there usually is a survivor. COP's personal philosophy is, I consider the victims to be alive until I see a dead body to prove otherwise.